Alright, hell yeah. Statics. Chapter 1. Problem 9. Alright, here we go. We're going to do it. And this one's just like a crazy one. It's just like it's a think outside the box. A geometry textbook gives the equation of a parabola as y is equal to x squared. We've all done this one. But the crazy thing is they say where x and y are both measured in inches. That's true. And so how can this equation be dimensionally correct? And it was just like, oh, okay, so I've already thought it all the way through, and it's not dimensionally correct. You know what I mean? So you have inches, so you have y is equal to x squared. You have inches over here, and then inches squared over there. Not correct. So they want to know, how can this equation be dimensionally correct? They don't say, is this equation dimensionally correct? They say, hey, how can it be? And you know what I mean? It's the same thing with the force in the spring. Here it is the force of a spring. Now, you could just say the force of a spring is equal to the distance. F is equal to x. That would make this equation even simpler. This force and spring equation is simple enough. But how would this be possible? Well, it would say, so you have a spring, just doing its thing, and it ain't doing nothing. And the distance right here, x, is equal to 0. So the force on this spring is 0. Okay, and then you go hang on it, you know what I mean? And then it drops down to here. Whoa. I don't know if that's a human person at all. It's got 4 arms. But anyway, and so now you have a distance x down here. And let's say you weigh 600 newtons. Well, the only way this force would be correct is if you went 600 meters. You know what I mean? So maybe this is just a really weak force. You know what I mean? And a really stretchy string. Real stretchy string. But if you go 600 meters, when you put your weight on this, then the distance you travel will be 600. And guess what? That's going to be equal to 600 newtons. 600 meters equal to 600 newtons. Okay, cool. Those aren't dimensionally correct, but how do we make it dimensionally correct? Well, we put a constant. So I guess that was a long way to say, hey, just throw a constant out here and do that. Y is equal to constant x squared. Now, we're typically used to constants, being, in reality, I did a problem where this went down 0.1 meters. You know what I mean? 100 millimeters, 4 inches. You know what I mean? And I weigh 600 newtons, so we want to know the spring constant. So 600 newtons is equal to K times 0.1. You know what I mean? Bring the 0.1 downstairs, that's multiplying by 10, and your K is going to be, and this is in meters, 0.1 meters, so your K is going to be 6,000 Newton meters. You know what I mean? So there you go. So your spring constant for this spring, if I hang on it and it comes down 4 inches, 6,000 newtons per meter. Okay, cool. So we're used to spring constants being like big values, small values, or at least something. I mean, the gravitational is 6.67 times 10 to the negative 11. You know what I mean? And, oh, hell yeah, I can do this one in my head now. Before we get to this. Yeah, because it's so interesting. You know what I mean? MM over R squared. Hell yeah. So this G G has to have a force. So it's got to have a newtons. It's got to divide out those 2 kilograms, and it's got to divide out that multiply out those 2 meters. So there you go. So at the end of the day, after doing these problems so much, it's just hell yeah. Now I can use all the tricks of the trade, and within 10 seconds, I can get the units on the gravitational constant. I ain't memorizing that. Hell no. I'll memorize this and then get to that. Okay, so let's do it. So we just figured out that a constant of integration can be applied anywhere, and in this case, the constant integration is just 1. You know what I mean? It's got a value of 1. It doesn't change the equation at all. And now we have inches is equal to K times inches squared. You know what I mean? So now we have inches over here, but we already have too many over here. So K is just 1 divided by inch. You know what I mean? And then or you could have just said, hey, we need to make these balance. So isolate K, and then you got K is equal to inches divided by inches squared. And that's going to be 1 over inch. So there you go. I think that answers the problem. It says, how can this be dimensionally correct? Add a constant of integration with units 1 over inch. You know what I mean? Because then you'll have inches squared times 1 over inch. That'll be inches. And that'll be dimensionally correct. Alright, well thanks for joining me. I don't know if that one's right at all, but we learned a lot. And guess what? That's a video.